Improvement, even in what ought to be unfilled space, complicates our idea of a genuine void and suggests that, yes, even before the Big Bang there was something. Analysts are still exploring this. One of the most intriguing theories in current cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue endlessly. Brian Cox describes an extraordinarily vast inflationary multiverse, where universes are continuously created and expand. Imagine each Big Bang as a spark igniting another universe while inflation occurs in various regions, creating countless other universes. This process could, in theory, go on forever. This idea of gigantic universes giving rise to others leads to an enchanting concept of a fractal universe, where each new universe may, in fact, create its own Big Bang. Each universe exists as an independent space, unaffected by others. For researchers, this theory is both thrilling and unsettling, as it suggests a relentless multiverse with no clear beginning or end. Imagine our universe as just a speck in a vast, infinite chain, constantly developing and continuously giving rise to new universes. And what if this is the true nature of reality? There is no before or after, but rather an eternal pattern of universes forming. Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not simply a collection of matter floating in space but a complex network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and vanish within these fields, briefly borrowing energy before returning it. This characteristic leads to virtual particles, entities that exist momentarily and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have absolute nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain active, sometimes creating transient particles. This constant activity in what should be nothing suggests that the universe does not conform to our concept of emptiness. The fields and forces persist, filling the universe with latent energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles and particles create matter, could the actual universe have emerged from this nothingness filled with quantum fields? Dark energy, an enigmatic force that currently drives the accelerated expansion of our universe, adds another layer of mystery. Did dark energy exist before the Big Bang? According to some perspectives, the presence of dark energy today is a consequence of an energy field that existed before our universe's formation. The properties of dark energy suggest a powerful force that could have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, might have driven the inflationary phase, causing rapid expansion. The existence of dark energy implies that, even if our universe were emptied of all matter and radiation, this force would continue to shape the fabric of spacetime. This idea raises a profound question. If dark energy existed before the Big Bang, could it have created the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation or even the true beginning of our universe? Another theory, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory suggests that the universe undergoes massive cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal cycle where universes develop, collapse, and regenerate in a new cycle. This theory proposes that our universe may have been reborn from the remnants of a previous universe. In the space of science and immense favored experiences, the subject of what existed early on to the colossal effect has mixed discussions and captivated characters for a long time. This Goliath demand doesn't simply test how we could unravel the universe. It challenges the certified farthest objectives of human information. Envision standing at the edge of existence, analyzing the enormous shadowing, and considering what lay there before our universe was envisioned. The occasion of the huge explosion, Big Bang, denoted the start of history, space, and what we know. In any case, there was a moment before that. Could there have ultimately been a state of nothingness, a quiet before the blustering gathering began? And if this is true, was it? Or perhaps, there was something even more disturbing that existed before time itself. As we dive deeper into this question, science takes us on a journey beyond the universe's early phase, into contemplations that challenge our understanding. Physicist Brian Cox, known for his contributions to the wonders of the universe, suggests that something stunning could have existed before the huge explosion. He challenges us to rethink our perception of the material world and existence. In this analysis, we'll explore the science, the theories, and the puzzling mysteries that could explain what existed before everything. We'll investigate ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered may astound you, but they could also open new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination. Science, where the unknown still lingers in the shadows, leaving researchers both amazed and, at times, unsettled. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. The Big Bang, as scientists describe it, refers to the moment when the universe became extremely hot and dense, expanding rapidly to trigger the formation of all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a starting point. But why did this happen? And was there a time before this dense, hot start? According to the theory of cosmic inflation, there was certainly a before, and it was far from empty or calm. Cosmic inflation proposes that before the Big Bang, the universe was in a state that was cold, empty, and free, almost like a mythical vacuum. However, this vacuum wasn't entirely empty. It contained a massive amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially set the stage for everything that would follow. In a fraction of a second, space expanded at extraordinary rates until the expansion slowed down, and the energy transformed into matter, particles, and the forces we associate with the Big Bang. But what was the nature of this energy? Why did it emerge seemingly from nowhere to create the universe? And why did it stop? Scientists believe that this infinite expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with small air bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly countless Big Bangs and an infinite number of universes. Ours is just one of many. This mind-bending reality challenges how we interpret the universe itself and leaves us with a question. What else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least to our current understanding. Even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave a complex tapestry of something, even in its emptiest form. Even if we imagine stripping away these forces, leaving a void, the universe would still create new kinds of energy. This reality is baffling to scientists as it suggests that true nothingness may be impossible within our vast understanding. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with literally nothing in it. No particles, no radiation, no energy. Yet, quantum fields and cosmic constants would still exist, implying that this nothingness has properties. For instance, there is a concept called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still appear and disappear, creating a faint echo of